And in the tensile testing, you can see that these lines don't match up, which means parts printed in different directions, they have different properties. And the properties are listed here. This is a strength of only 10 compared to strength of 21, which means part can be 50% weaker if you do not print it in the right direction. So that's an important lesson. We not only need to understand the technology, we have to understand it deep enough so that we can decode problems like this, the way they may happen. We can also do elaborate tensile testing here by printing them in different orientations with the parts with internal surfaces. In some cases, you will see the effect of internal surfaces reducing the strength, and in some cases, you will not see this effect of these internal surfaces, and you will get high quality parts. So those things, some of them will come only with practice when you understand the technology better. And here we have tried to print that part with the same surface in different orientation. So the vertical orientation does not even print this part in a powder-based method in XZ orientation, while XY orientation prints the part, but it has a discontinuity here, giving you the poor quality. This is a resin printed part. This also shows you discontinuity in XZ, but the XY is high quality. So the orientation of part on the build plate itself is an important lesson that comes out of these examples here. And you can try some of these things on this printer right here. It's available here to conduct the same studies. And the parts that you are printing here today, maybe you can take them to one of the CT scans or X-ray machines. You can put them inside and look at the porosity and look at the internal features and find out how they check out here. So even on the most expensive printers, this printer that printed the specimens that I'm showing here, this printer is almost $750,000, but it still gives you different properties in different directions. Although with more expensive printers, you do get better quality in the products right now. So just the orientation of these parts on 3D printer build plate, it makes a big difference, so you should be always careful about that part. So finite element analysis is extremely important these days in any field, and in dental implants or medical implant fields, there is a lot of value. And one of the reasons why we try to use them in these fields is the complex geometries. So anytime you have these sharp features are where the failure will take place or fracture will take place. So we try to minimize these sharp features, and we try to replace them with more smooth contours compared to what you see here now. So this is more smooth contours. But how smooth is smooth enough? That decision is only taken place once you conduct all these analyses. So red color means bad, it means a lot of stress concentration. And in this case you can see that the red is more distributed here, and the amount of red is more uniform compared to concentrated point here. So the performance actually increases as you redistribute these loads from sharp corners to more uniformly around the specimen here. So this is a study we conducted on 5 different dental screws in trying to see which one of them provides us better confidence in a patient. And the study was combined with a number of other factors like how much bone a patient has, how deep the screw goes, and the mechanical properties of the bones which are surrounding these tissues, these implants. And we came up with the guidelines on how these implant designs can be best utilized in a patient based on the bone quality and the amount of bone and also the mechanical properties of the bone itself. Some of the tests that you can do on the data you can infer just simply from the imaging capabilities which are out there these days in dental fields. So this paper has been published a couple of years back. You can look at that. So this analysis was not simple mainly because these teeth are right next to each other. And when you put one implant here, the stress field created by this implant actually impacts the stress field created by the tooth which is right next to it. So that interaction between the stress field is extremely important. And that was part of the learning process here. So in the summary, the message that I'm trying to give you is that this is a highly evolving field. It's a good time to get into this field and define the field the way you really want it for your profession in the long term. The governing bodies like Food and Drug Administration in the USA, they have been very
regimens regarding small things like how to print complete implant, 2 different materials. But if you want to ask anything specific from this complex, simplified presentation, you are free to ask. Otherwise, we will take a break now. Anybody has anything? Yep, here.
Doctor, you mentioned about how it's going to be the current state of the technology that it's going to be the current state of affairs that a model is good. Homogeneity of the surface is always going to be varied. Correct? That's true. Okay.
that I showed on many slides. So how do you as a user deal with that kind of inhomogeneity when you do this work day-to-day practice? It's a worry for many people actually out there in different fields. And you can imagine that aerospace fields where one failure can cause loss of life for a lot of people. They are extremely worried about things like that. Right now, the reason this happens is because the resolution of this printer in X and Y and the vertical direction, they are different. So there is a lot of work going on in changing the control algorithms so that you get the same properties in all 3 directions and it does not remain a problem. But the reason this happens is now because of the complex geometry. And if I give you a complex design, and if I say that why don't you copy this design using a pencil without lifting the pencil from the paper and just make it without overlap or anything, is just create this drawing in 2 dimensions. So that's the kind of complexity you have right now. You somehow have to deal with that. So the pencil has to come back and forth in some locations, it has to go in circles in some other locations. But there are optimal solutions which will be developed in future that I expect.
What's the kind of the state of
Yeah, this one. So this is created by a printer that costs $750,000. And you can see that the properties are very close to each other, but still not the same. A printer like this, which is only $1,500, you can expect 50% variation in properties with the same type of data. So for practice, these are excellent printers. For education, I like these printers because you have variation in properties and people can become more and more conscious about it. But when you go to practice in building real implants, you would really have to go to something like this. If you start by using only these for education, people sometimes don't appreciate the kind of problems that happen. So I'm teaching a course on additive manufacturing right now. And my students are only using these printers so they can have a wide range of property variation. And once they suffer, then only they know how to deal with the development of the best possible model. Thank you.
Complex things in our institute. Hopefully we will have this full time here. So please have a look at this one. And we also have a visitor from Bangalore, Genotypic Technologies. So they have a technology to sequence complete genome in 2 hours. So we will try to see if we can arrange a demo for them as well. Thank you very much. And I would like to welcome Dr. Falguni Pati IIT faculty. Just arrived. Thank you very much, sir. He will be speaking after lunch. Thank you, sir. And now we will take a break. Thank you. So if you think of a 3D project, what are basic things you will be known? So they will be he tried to make it very simple. So please pay attention. So if you follow the presentation in the end, you will be able to know when you think of some 3D process or 3D printing, what are things you need to think of. to introduce little more about Dr. Mrityunjai. And some of you are already familiar because of the webinar and later on so many of the emails you sent regarding the 3D printing and 3D printing of 2 different materials, metal 3D printing, biocompatible printing. So he was already working with Dr. Kader and few of the dental faculty. His expertise is with the additive manufacturing process, and he has a very nice facility in NITK Surathkal. Thank you very much for extending your help. Now, with this brief introduction, I will invite him to explain about the process. Thank you very much.
Opportunity to share few of the things which we do at NITK. I thank management too for being so supportive in inculcating this research culture, especially in the medicine community, with whatever help they can do. In the morning when I was coming, I was pretty nervous because of this white colored coats, and then I got comfortable because of the blue colored ones. Because being a mechanical engineer, the blue color is very close to our heart. When we use that as an apron for workshop or in machine shop, so I was pretty comfortable then. Okay, thanks a lot. So I'll just take this opportunity to just share, and I'll prefer walking around